Hello friends, welcome to Efficient Learning World. So this is the first video of the sorting algorithms playlist. So in this whole playlist, I will talk about the sorting. For example, what are the sorting algorithms and their types like insertion sort, merge sort, quick sort, bucket sort, team sort, and each and everything their time complexity, space complexity of the sorting algorithm. So before starting the types of the algorithm, we will discuss the sorting algorithms. That what are they? So in this video, our major concern is basically about that what are the sorting algorithms, what are their types, what are their advantages, and what are their applications. So in the upcoming videos, I will explain the sorting algorithms types one by one. Okay, so before starting sorting algorithms, let's discuss what is sorting. So the process or the operation of ordering items and data according to specific criteria. When I say ordering items or data, it means, for example, you have random integers, 10 integers, 8, 9, 5, 4, 3, 2, 1, 10. Okay, and you want to sort them. So the ascending order will be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or the descending order will be like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So you can sort these integers. So sorting is basically the process or operation of ordering items and data according to the some specific criteria. Specific criteria will be given in the question, or if some have requirements. Okay, so for example, you can have the card example. Let's discuss a simple example of the cards. For example, you have some cards, okay, and each card contains an alphabet. Okay, for example, these are 8 cards and each card contains alphabet like A, E, F, C, J, I, K, D, and I want to sort these 8 cards. So the order will be like A will be placed here, then C will be placed here, then D, then E, and then further on. So how I will sort these? I will use some operations. For example, I can compare them that what that E's alphabet, that the alphabet E has a higher ASCII code or Unicode than as compared to F. Okay, so whatever the operation or the process I will compare them, or I will use some technique or some methods, and after sorting I will put these cards in some order that will be the sorted order. Okay, so this order will be like A, C, D, E, F, I, J, K. So this is ascending or in ascending order, and you can also sort in descending order. Okay, so how we can sort these data. Okay, so we need some algorithms, we need some technique, we need some methods. So that method is known as algorithms, and that algorithms is basically the sorting algorithm. So the methods of reorganizing a large number of items into some specific order, such as highest to low means ascending order, or vice versa, or even in some alphabetical order. Alphabetical order, I have already explained the alphabetical order in previous slide. Okay, so one important note is that these algorithms just take an input list. Input list means, for example, you have an array of 10 numbers, okay, and you want to sort them, and then it will process it means it will perform some operations on it, like comparing the adjacent nodes, or it will put some use some bucket methods, or some adjacent method use it will use some methods and perform some operations depending upon that algorithms technique or method. Okay, and after performing the operations, it will produce the sorted list that will be over required output. Okay, so sorting algorithms are a lot of applications in the machine learning. Okay, so it is a basic and most one of the most important part in the coding courses. For example, as I already explained, that you can have an array of 10 integers and you want to sort them, but depending upon the criteria, that either you want to sort them in ascending order or descending order. So ascending order will be like 1 2 3 4 5 6 7 8 9 10, and descending order will be like 10 9 8 7 6 5 4 3 2 1. So using some technique, you can sort them in ascending or descending order, but this is very simple, that you have only 10 integers and you sort them. But what will happen if you have 1 million or 1 million integers? So it will be quite difficult. So using some specific particular efficient algorithms, sorting algorithms, you can sort easily that integers, so that retrieval will be easier. Okay, so sorting algorithms are a lot of type. For example, insertion, sort, selection, bucket, merge, heap, insertion, counting, quick, shell, entry, and there are lots of sorting algorithms, and I will explain each and everything in the upcoming videos about these sorting algorithms. So for example, I will explain the insertion sort, their pseudocode, their time complexity analysis, space complexity analysis, okay, and the coding part also. I will explain in the upcoming videos about all of these sorting algorithms. So let's discuss the advantages of the sorting algorithm. So simplicity and ease of implementation. It helps in managing the data. When you have a lot of data, for example, millions of information about some students or some have any data. Okay, fast and efficient and fast retrieval of data. For example, you want to search a particular record of a student in the college. So if you have lot of data in your database, so for fast retrieval of data in the for fast retrieval of the data, you will use some sorting algorithms. So applications of sorting algorithms will be commercial computing, numerical computation, search for information, operation search, event driven simulations, and dictionary as well. You see, whenever you open the dictionary, so it will have all the words in the alphabetical order. First A word will be given, and then B, then C, and then further on. So these are some applications of the sorting algorithms. So thanks for watching this video. This is it for now, but in the upcoming videos I will explain the types of sorting algorithm. So thanks for watching this video. If you have any ambiguity, you can ask me in the comment section.